All righty. Okay, so the roadmap that we want to be really thinking through is what from the notes on Wednesday. You could see those. They're online if you want to go back and look at that roadmap. But really, when you're working these problems, you really, in your mind, you want to be thinking, and this will get repetitive, but grams of A to moles of A, moles of A to moles of B, moles of B back to grams of B. So the quicker you can be with this, the better it's going to be. We're going to be able to see that we can go from moles of A to molecules of A, or B, molecules of B, or molecules, I'll go down here, molecules of A. So you could start with grams of A and end up with molecules of A, all right? That was that one in our notes that was this way, it's horizontal, the first one we saw. You could go from grams of A to molecules of B, right? You're just going to have 1, 2, 3 equivalencies. Or you can go from grams of A to grams of B, and you're going to have 1, 2, 3 equivalency. Each of these arrows is an equivalency. Okay? Now, what we're going to do here shortly is then we're going to complicate this even more when we start to talk about molarity. All right? So that's when we start to get into solutions. But this thing is growing. And so for now, where we're at is we're here, we're working here today and probably some here. Okay, so this worksheet, most of this worksheet is helping us with understanding how do I go from grams of A to moles of B? How do I go from grams of A to moles of A? Okay, well I only need one, I need the molecular weight, okay, the molecular mass. So we left off with this simple equation where we take hydrogen gas plus oxygen gas, and we go to water. So the very first thing I have to do in my equation, both on the exam and in the worksheet today, is balance the chemical equation. So that's why we work through the exercise and making sure we are quick and comfortable with balancing chemical equations. So that said, we're going to have 2 hydrogens, 2 hydrogens, 2 oxygens, 1 oxygen. So I need to put a 2 here, so I have 2 oxygens, 2 oxygens. Now all of a sudden I have 4 hydrogens, so I need 4 hydrogens, and there this stoichiometry is balanced, okay? So that's my balanced chemical equation. So we left off talking about what if we took 25 grams of hydrogen, how many grams of water do we get out, okay? So what I want to do now is go, what if we started with 25 grams, what if we didn't start with 25 grams of that, let's say that was excess, and we start with 25 grams of oxygen. We start with 25 grams of oxygen, how many grams of water can we produce? So once again, if I'm going from grams to grams, I want to be thinking grams to grams is 3 steps along the roadmap. It's 3 equivalencies. Grams, 1, 2, 3, back to grams. So I put my 25 grams, 25.0 grams of oxygen now, and because I'm going to have 3 equivalencies, I'm going to have 3 equations. Like I said on Wednesday, these are equivalencies. These are equal to one another. So they can go either way, on top or on bottom. What drives it is what I start with. So I know grams of oxygen goes down here, which puts moles of oxygen up here. If moles of oxygen's up here, moles of oxygen goes down here, moles of water goes here. If moles of water's here, moles of water has to go here, which leaves me with grams of water. And if you set the whole thing up correctly, just like we were working on, the grams of oxygen should cancel with grams of oxygen, moles of oxygen, moles of oxygen, moles of water, we should be left with grams of water, which is exactly what we want. Okay? So now all I'm going to do is go plug everything back in. All right, so I've been given 25 grams. I know 1 mole of oxygen is 32 grams. I know my stoichiometric ratio is 1 to 2. So it's 1 to 2. Okay? And I know that 1 mole of water weighs 18 grams. Now, when you're doing these on the exam or when you're doing these in the real world, Your molecular weight, your molecular mass here and here should never be the limiting reagent. Or excuse me, should never be the least significant figures, okay? Because on the periodic table, we can always take that out past the 3. So this drives the significant figures on my answer. So since I have 3 here, I have to have 3 in my answer, all right? So if I do take my trusty dusty calculator, and you don't need big fancy calculators for you, I borrowed this one from Audra, it's a real simple calculator. So 25 divided by 32 times 2 times 18 equals 28.1. Okay? Now, any questions on that? Yes? 18 is the molecular mass of water.
Okay.
Yep. Oxygen, 16, 2 hydrogens. Okay, so think this through. Let's say I didn't start with 25. Let's say the question was worded this way. Let's start with 37.2 grams of oxygen. How many moles of water do I get out? Now that's a different question. So let's think about the roadmap. If I start with 37 grams of oxygen, how many moles of water can I get out? Well, notice what happens with my roadmap. If I'm starting with grams of A, oxygen, moles of A, moles of water. I only have 2 equivalencies. So in this case, the equation is going to look like this. 37.2 grams of oxygen. Again, I looked at my roadmap and I know I'm going to stop there. Okay? I'm not going to go all the way to grams because the question is not asking for grams, it's asking for moles. Again, I fill it all in. Grams of oxygen, moles of oxygen, moles of oxygen, moles of water. Cancels, 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 cancels. I'm left with what the question asks. So I only have 2 equivalencies there. So now all I do is go back in, I put my 1 here, my 32 there, I put my 1 here and my 2 here, and notice when I do this, going from grams to moles, it's a shorter equation because again I'm stopping at moles. So 2.33. Okay? So depending on what the question's asking, depends on how much of the equation or how much of the roadmap I use. Let's say the question asked how many molecules of water do you, if I started with 15 grams of hydrogen, how many molecules of water would I get? Okay? So now what I want to see is, well, okay, I'm grams of A, and I'm at molecules of B. So I need to go from grams of A to moles of A, moles of A, moles of B, moles of B, molecules of B. So this is molecular weight, this is stoichiometry, this is Avogadro. So let's set it up. If I start with 15 grams of hydrogen, I'm going to have 3 equivalencies. 1, 2, 3. Okay? So grams of hydrogen, moles of hydrogen, moles of hydrogen, moles of water, moles of water, molecules of water. Okay? So, I'm going to make that one a little bit bigger there, Hannah. Make that one a little bit larger. Moles of water, molecules of water. Okay? So it's all set up. What's the question given? It's given grams of hydrogen. What's the question asking for? Molecules of water. Again, everything should cancel. And if it does, then you should get the right answer if you can plug in the right variable, the right numbers. 1 mole of hydrogen weighs 2 grams, round it off. My stoichiometry here, which is kind of simple, it's a 2 to 2, but 1 mole of water is 6.022 times 10 to the 23 molecules of water. Okay? So my calculator doesn't actually do exponents, so I'll just do 15 divided by 2 equals, so 7.5, and then I'll let you, if you want to plug it into your calculator. So this is going to be 7.5 times 6.022 times 10 to the 23rd. So if we want to actually do that, times 6.022, I'll just do it the old school way. It's going to be 4.5 times 10 to the 24th molecules. How many significant figures do I have? Let's go 2. Molecules of water. Okay? Yes? Is that a question? So you see how important it is to follow the roadmap? Because again, depending on what the question gives you, depends on how you apply it, right? So for example, what else could be done? Well, let's say one last example of this. Let's say I started with 3.2 moles of water. How many grams of water can I get? Or sorry, moles of oxygen. Well, now notice what's been given. Oh, well now I'm here. And so I need to go this way, and I need to have 2 equivalencies. Does that make sense? Because I'm starting with moles, not grams. So in that case, 3.2 moles of, what did I say, oxygen? I'm going to have 2 equivalencies. 1, 2. Moles of oxygen down here. Moles of water here. Moles of water here. Oh, grams of water here. Again, everything should cancel nicely, and it does, left with what I'm asking. So, plugging this in, I know my oxygen is a 1 to 2. I know water is 18 grams per mole. And we should be pretty much good to go. So if I take my trusty dusty calculator and take 3.2 times 2 times 18, it equals 115 grams. Okay? We good? You've seen me do a lot. But again, you don't learn chemistry by watching me do chemistry. You learn chemistry by doing it. Now, here's where we're headed with this. So stay tuned. Here's where we're headed. What we're going to do on Monday, what happens if I have 15 grams of hydrogen and 15 grams of oxygen? How much water can I produce? One of those is limiting. And I'll tell you right now, it's probably the oxygen. Okay? But we have to figure out how that is. So that's what's Monday. Then on Wednesday, what happens is, this is what we call our theoretical yield. That's the most I can get if I have 100% conversion. If all 3.2 moles goes to water, I get 115 grams out. But when I actually do this reaction, most of the times I don't get 115. I might get 107. What's my percent yield then? And I've had students that get 125 on a reaction. And it's because they did a bad calculation or their finger was on the scale. Okay? So again, we have to understand percent error and percent yield. Okay? And that's Wednesday. So that's where we're headed. So let's make sure roadmap is solid today. Questions on that before you jump in on your own? No? All right. Your turn.